So I'm going to do one example for negative charged molecules. I'll start with the PO43 minus, and then I'll do another video with like one difficulty level up for a different negatively charged example, just because it can kind of get hectic real fast, so we'll just work you up. Same steps, so don't panic. First step, valence electrons. Phosphorus is under nitrogen, so group 15, so it wants 5 valence electrons. There's 4 oxygens, each of them bringing 6. So that would be a total of 29. But I know there's a charge on my molecule. A 3 minus charge means that this phosphate has gained 3 extra negatively charged electrons from anywhere. So that's not going to be within our count. So we have to know to add that just because of that 3 minus. We'll add 3 full electrons for a total of 32 valence electrons to draw now. If it was a cation, that means it would have lost electrons, so you would have subtracted, but because it's an anion, you gained electrons, so we add them. So the next step is to take the guess. I know phosphorus is going to go in the middle because there's more oxygens to go around it. And I'll space the oxygens out as far apart from each other as they can get. So in that guess, I've used up 8 electrons from my total. And now I only have 24 electrons to draw. And when you're first guessing, you're just going to throw them around the peripheral atoms, so the ones outside on the bonds, so the oxygens in our example. So it'll be 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26. Wait, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 20, 22, 24, 26, 28, 30, 32. Somewhere along the way I miscounted there, but we still have our total of 32, all in this guess. So that's our guess, and we just now have to check formal charges to see if we have to fix anything. I'll do it for the oxygens first. So just to remind you of the formula, it's going to be the valence electrons or the group number minus however lone electrons it has minus half of the bonding electrons. So oxygen is in group 16, or it wants 6 valence electrons, minus 2, 4, 6 lone electrons, minus half of the 2 electrons in that bond, leaving it a -1 charge. So each oxygen in our drawing has a -1 formal charge on it. That means that overall right now, the molecule has a -1 plus -1 plus -1 plus -1, so it has a -4 charge overall, but we only want a -3 charge overall. So let's just check phosphorus. It's in group 5, no lone electrons, and half of the 2, 4, 6, 8 electrons in the bonds around it. And that's the +1. That'll balance out our total charge to be the -3 now. So that's pretty good. So let me try to clear things up a little. I'll just redraw everything. So right now we look like this. Phosphorus in the middle. Oxygen. Oxygen, oxygen, oxygen. Negative charge, negative, 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 with a plus in there. And each of those oxygens had 6 lone electrons. So the rule is for formal charges that the charge on the molecule has to be the same as the sum or adding up all the charges on each element. So we work out, we have a +1 on the phosphorus and -1 4 times for each electron, which leaves us an overall of -3. So that is what we wanted. But then there's this other rule that takes it one step further and says, do your best to make the formal charges be as small as possible. So if you can, make an element that has a formal charge not have a formal charge anymore by redrawing your guess. And the only way to do that is by making double bonds. This negative charge on this oxygen over here says that it has, sorry, I just erased an electron there, says that it has extra electrons on it. The positive charge on the phosphorus says that it needs extra electrons. So the best way to figure that out is if I could donate 2 of these electrons from that oxygen into a bond to form a double bond there, that would gain electrons on phosphorus and give up electrons on the oxygen. So hopefully that would even things out. So let's try it. Now that oxygen will only have 2 lone pairs, or 4 lone electrons. One, 2, 3, 4, 5, 6. And now we can check formal charges again. I don't have to check the formal charges for these oxygens because these look in the exact same arrangement that they have 6 lone electrons and 1 bond. And I've already calculated the formal charge for that arrangement. So I'll just have to do it for the oxygen that looks different now. Group 6 minus 2, 4 lone electrons, minus half of 2 electrons in that bond, 2 electrons in that bond. So that's 4 bonding electrons. That leaves us 6 minus 4 minus 2, so that's a 0 formal charge. So that's good. And then let's check phosphorus, which should hopefully also have a 0 formal charge because we just want a minus 1, minus 1, minus 1 to give us the minus 3 charge on the molecule. So phosphorus should be group 5 minus no lone electrons minus half of 2, 4, 6, 8, 10 bonds. Sorry, 5 bonds with 2 electrons each, so 10 bonding electrons. And that's the 0 back. So the final drawing for this molecule has that double bond in it. That's the most stable arrangement. So it would be 1 phosphorus in the middle, double bond O. And you don't have to draw lone electrons around the outer atoms. You would only have to draw them on the A or the central bond, like the phosphorus here, if you did have them in your final answer. So in this case, I can ignore the ones all around oxygen. So VSEPR notation is 1A for the central phosphorus. And I have 1, 2, 3, 4 bonding things, so X4. And I have no electrons on that phosphorus, so no E. That makes this tetrahedral. So in 3D, it should be O in the plane, O in the plane, whoops, O coming out at you, and O going back at you. And the bond angles there being 109.5. So that's all you would need to know, just that right side of the screen here.